Venus is the second planet from the Sun and is often called Earth's sister planet due to its similar size, mass, and composition. Despite these similarities, Venus is a drastically different world with a hostile environment. Here's everything known about Venus. Venus has a diameter of about 12,104 kilometers, which is approximately 95% of Earth's diameter. Venus has a mass that is about 81.5% of Earth's mass. Venus has a density of 5.24 grams per cubic centimeter, which is slightly less than Earth's 5.52 g/cm superscript 3. The gravity on Venus is about 90% of Earth's gravity, meaning you would weigh only slightly less on Venus than on Earth. Venus orbits the Sun at an average distance of about 108 million kilometers, 72 cents, making it the second planet from the Sun. Venus completes one orbit around the Sun in 225 Earth days, meaning a year on Venus is shorter than on Earth. Venus has an exceptionally slow rotation, taking 243 Earth days to rotate once on its axis. This is the longest rotation period of any planet in the solar system. Venus rotates in the opposite direction to most planets in the solar system, meaning it rotates retrograde or clockwise, while most planets, including Earth, rotate counterclockwise. As a result, the Sun rises in the west and sets in the east on Venus. Because Venus's rotation is so slow and its orbit so fast, one solar day, the time between sunrises, on Venus is about 117 Earth days long. Venus's surface is obscured by thick clouds of sulfuric acid, but radar imaging from spacecraft has revealed its landscape. Key features include: Venus has numerous large shield volcanoes, including Mont Mons and Sif Mons, some of which are potentially still active. Volcanic plains cover much of the planet's surface. Tesserae. These are regions of highly deformed terrain, with ridges and valleys, found on Venus. The tesserae may be among the oldest surface features on the planet. Venus has far fewer impact craters than Mercury or the Moon, indicating its surface is relatively young, likely due to volcanic resurfacing. The presence of craters also suggests the planet does not have plate tectonics like Earth, as there is no active recycling of the crust. Coronae. These are circular volcanic structures, some spanning hundreds of kilometers, formed by the upwelling of hot material from the planet's interior. Venus has a thick atmosphere, composed mainly of carbon dioxide, CO2, 96.5%, with traces of nitrogen, N2, 3.5%, and small amounts of sulfur dioxide, SO2, and water vapor. The surface pressure on Venus is about 92 times greater than Earth's, equivalent to the pressure found 900 meters underwater on Earth. This immense pressure would crush most spacecraft and human habitats instantly. Venus has an average surface temperature of 465 degrees Celsius, 870 degrees Fahrenheit, hotter than Mercury, despite being farther from the Sun. This extreme heat is due to a runaway greenhouse effect caused by the thick CO2 atmosphere trapping heat. The planet is enshrouded by thick clouds of sulfuric acid, which reflect about 75% of the sunlight that hits them, making Venus one of the brightest objects in the sky. These clouds also contribute to the planet's greenhouse effect. Upper atmosphere has superfast winds that blow at speeds of up to 360 kilometers per hour, 224 miles per hour, circling the planet in just 4 Earth days. Although the exact details of Venus's interior are not well known, it is thought to have a similar internal structure to Earth. Venus likely has a large iron-nickel core about 3,000 kilometers in radius, similar to Earth's, though it is unclear whether the core is molten or solid. Above the core is a silicate mantle, which is believed to drive volcanic activity on the planet. Venus has a thin crust, thought to be composed primarily of basalt. Unlike Earth, Venus does not have active plate tectonics, so its crust is relatively static. Recent studies suggest that Venus may still have active volcanoes. Some regions show signs of recent lava flows, and there have been periodic spikes in sulfur dioxide levels in the atmosphere, which may be linked to volcanic eruptions. Venus's surface is relatively young, estimated to be about 300 to 500 million years old, indicating that the planet undergoes periodic resurfacing events, likely from widespread volcanic activity. Unlike Earth, Venus has almost no intrinsic magnetic field. This is surprising given its similar size and internal structure to Earth, which has a strong magnetic field generated by the movement of molten iron in its core. The lack of a magnetic field on Venus may be due to its slow rotation or a difference in the way its core behaves. Venus has been visited by numerous spacecraft, both from Earth orbit and through flybys and landers. Venera program. Soviet Union. The Venera missions were the first to successfully land on Venus and transmit data from its surface. Venera 7 was the first spacecraft to land on another planet and send back signals, while Venera 9 sent the first images from Venus's surface. Pioneer Venus, NASA, 1978. This mission included an orbiter and several atmospheric probes, studying Venus's atmosphere and mapping its surface using radar. Magellan, NASA, 1989 to 1994. The Magellan mission used radar to map 98% of Venus's surface in high detail, revealing its geologic features like volcanoes, rift valleys, and craters. Venus Express, ESA, 2005 to 2014. Venus Express studied the planet's atmosphere and confirmed the presence of ongoing geologic activity, as well as superrotating winds. Akatsuki, JAXA, 2015. Present Akatsuki is currently orbiting Venus, studying its atmosphere, weather, and cloud patterns in detail. Evidence suggests that Venus may have once had significant amounts of liquid water on its surface. Some models predict that Venus might have had oceans in the distant past, possibly for as long as 2 billion years, before the runaway greenhouse effect evaporated them. Today, Venus has almost no water. Its atmosphere contains only trace amounts of water vapor, and any liquid water that might have existed in the past has long since evaporated and escaped into space. Venus may have undergone a significant climate transformation. Billions of years ago, Venus might have had Earth-like conditions with oceans and a more temperate climate. However, as its atmosphere accumulated more carbon dioxide, the greenhouse effect spiraled out of control, leading to the extreme conditions observed today. There is still debate about whether Venus is volcanically active today. Detecting active eruptions would help scientists understand the planet's internal structure and heat generation. Without plate tectonics like on Earth, it's unclear how Venus has managed to recycle its crust. Researchers continue to explore whether Venus has a unique form of tectonic or convective activity. In 2020, scientists detected phosphine gas in Venus's atmosphere, which led to speculation about the potential for microbial life in the planet's upper clouds, where temperatures and pressures are less extreme. However, this finding remains controversial and requires further investigation. Several upcoming missions are planned to study Venus in more detail. Veritas, NASA planned for launch in the 2030s. This mission aims to map Venus's surface in high resolution, study its geologic history, and investigate whether it is still geologically active. Da Vinci Plus, NASA also expected to launch in the 2030s. Da Vinci Plus will analyze Venus's atmosphere and may attempt to land on its surface. Envision, ESA set for a 2030s launch. This mission will focus on studying Venus's internal structure, atmosphere, and surface evolution, especially its volcanic and tectonic activity. Venus is named after the Roman goddess of love and beauty. In ancient times, Venus was known as both the morning star and the evening star because of its brightness and proximity to the sun. Venus is the third brightest object in Earth's sky, after the sun and the moon, and can often be seen at dawn or dusk, earning it the nicknames morning star and evening star. Venus is a fascinating planet with a history that may have been Earth-like in its distant past, but today it is a hostile world with extreme temperatures, crushing atmospheric pressure, and an opaque, acidic atmosphere. Despite its inhospitable environment, Venus remains one of the most studied planets as it offers insights into planetary climate, geology, and the long-term evolution of rocky planets. Upcoming missions promise to unlock more secrets about this mysterious planet.